Hi everyone, welcome to the Chemical Engineering Process Design Learning videos with Aspen Plus software. This is our fourth video lesson. This video lesson provides you knowledge and skills on using Aspen Plus software to simulate batch reactors, using chemical reaction kinetics to calculate the time required to reach a desired conversion in a batch reactor. We shall simulate a simple batch reactor problem as an example to get familiar with reactor design in Aspen Plus software. 2-butene is a 4-carbon alkene which has two geometric isomers. They are cis-2-butene and trans-2-butene. You can see the liquid phase irreversible isomerization reaction of 2-butene on the screen now. It follows first order reaction kinetics. Let's take the reaction constant simple K as 0.23 per minute. That is 0.003833 per second. We have to determine the time required to reach 90% reaction conversion in a batch reactor. First, let's see the manual calculation for this problem. We can apply the design equation of batch reactor for this problem and find out the time to reach 90% conversion. You can see the solution on the screen now. The manual calculation result gives an answer as 10.01 minutes to reach 90% conversion. Now let's see the simulation procedure and simulation result for this problem in Aspen Plus software. Create a new simulation in Aspen Plus using the blank simulation option. Specify cis-2-butene and trans-2-butene under the components. Rename the component IDs as cis and trans respectively. A warning message will appear saying that the component ID to be renamed. Click Yes. No changes happen to the component properties except the component ID. Go to Methods, Specifications Global Sheet. Set the base method field to non-random to liquid property method, which is abbreviated as NRTL. Click the Next button to populate the binary interaction parameters. Move to the simulation environment by clicking the Simulation button at the bottom left of the screen. Go to the Reactors tab of the model library and select R batch block and drop it to the main flow sheet. Connect two material streams for batch charge or feed and reactor product. Rename the streams and the reactor block properly by pressing Ctrl plus M or right clicking. Note that the R batch block can model a specified reaction using the kinetic data and specified residence time. However, it is still a steady state model. In the navigation pane, go to Reactions New. Select General for reaction type. By default, reaction ID R1 will be created, or you can create a new ID as you wish. Go to Reactions R1 and click New. Enter reaction 1 as the reaction name. So we type RXN1 in short form. Select cis-2-butene for the reactant component and trans-2-butene for the product component. As well, the stoichiometric coefficients in the balanced reaction should be 1 for both cis-2-butene and trans-2-butene. Notice that the coefficient for the reactants automatically becomes negative to mark the material balance. Click Close after completing the reaction. Then define the reaction kinetics. In reaction group R1, go to the Kinetic tab. Enter simple K is equal to 0.003833. Note that the default units for rate constant should be per second. Then enter activation energy capital E is equal to 0. We can see that simple K in Aspen Plus refers to pre-exponential factor. When activation energy is 0, the pre-exponential factor equals to the rate constant simple K according to Arrhenius equation. Keeping the mouse cursor over an input field will show the text giving information about it. Clicking into the field and pressing F1 brings up the Aspen Plus help page on the topic. Let's do this in the field for K to see the help page about the pre-exponential factor and the respective equation. Next, select the driving force button. Enter 1 as the component for cis-2-butene. Exponent specifies the reaction order in the kinetic rate law. After completing the input entries, close the window. In the navigation pane, go to Streams Feed Input. Enter 25 degrees Celsius for temperature, 1 bar for pressure, and a mole flow of 1 kilomole per hour for component cis-2-butene. Note that if you enter individual component flow into the composition section, it is not required to enter the total flow. Go to Blocks R-Batch Setup. In the specification field, select constant temperature and enter a temperature of 25 degrees Celsius. Note that this is not a realistic reactor temperature. However, our kinetics are not temperature dependent and it is acceptable for this simplified example. Next, enter the reactor operating pressure. You may enter the operating pressure by entering a pressure greater than 0, or you can specify the pressure drop through the reactor by entering a number less than or equal to 0. In this case, enter 0 for reactor pressure, which means that this reactor will not experience any pressure drop and will operate at the given feed pressure of 1 bar. In the Reactions tab, specify R1 as the selected reaction set. Specify stop criteria in order to stop computation when the conversion reaches a designated value. In this case, when the mole fraction of trans-2-butene in the reactor reaches 0.9, that means 90% conversion, reactor computations should be stopped. The product stream will have the composition of the reactor at this designated stop time. In the Stop Criteria tab, complete the input fields accordingly. Define operation time in order to create result tables and plots. Complete the input fields in the Operation Times tab. Total cycle time and maximum calculation time as 1 hour. Put time interval as 10 seconds. Specify number of points as 1000. All the inputs required to run the simulation have been entered. In the Home ribbon, click the Control Panel button. It is a good habit to open the control panel before running the simulation. The simulation should run to completion with no errors or warnings in the control panel. Note that in Aspen Plus software, the user has to run the simulation always, while in Aspen HiSys software, the user doesn't need to run separately as the software automatically runs the simulation. After running the simulation, it shows that results are available. Go to the Blocks R-Batch Profiles Compositions tab. The computed time at which the trans-2-butene mole fraction is 0.9 is shown as 10.01 minutes. which is identical to the manual calculation. To see the composition variation, select Composition Plot in the ribbon. For further analysis, we can perform following two variations. Go back to the simulation and first increase the stop value in the stop criteria so that we can see more results for longer time. Secondly, let's change the reaction constant. First, we take simple k is equal to 0.1 per second. Then we change it to 0.001 per second. We can see when the reaction constant is increased, the conversion reaches to 90% faster than previous, and vice versa happens when the reaction constant is decreased. Out of this video lesson, we can see that simulations help to study the batch reactor behavior with the possibility of changing parameters and more analysis. More importantly, when the reaction is complex with multi-components, the manual calculation is quite difficult, but we can still simulate in Aspen Plus software. You just need to add the components and change the reaction data. That is sufficient for any batch reactor simulation. Please watch our next video lesson about CSTR and PFR design simulations using Aspen Plus software. Until we meet with our next lesson, have a nice day and goodbye.